Charles's law can be defined as when the pressure of a specific gas is held constant, the volume of the gas is directly proportional to the temperature of the gas.
The formula for Charles' law can be shown as volume 1 over temperature 1 is equal to volume 2 over temperature 2.
Okay, here we have a basketball.
And we will be demonstrating Charles' law by using this basketball. We will first put the basketball into the freezer, and after a few hours we'll bring it back out and see what happens.
Okay, it's been 3 hours since we put in the basketball, so now we're going to take it out. And here's our lovely basketball. And as you can see, no rebound usage.
So, according to Charles' law, as the temperature decreases, the volume inside the ball also decreases. So, if we put it into the freezer, the temperature as it goes down, the molecules inside the ball also goes down, which means the molecules are more compact, thus causing the ball to contract and shrink. The initial volume of a basketball is 553.687 centimeters cubed, and the initial temperature is 25 degrees Celsius. When the basketball is placed inside a freezer for 3 hours, the volume decreases due to a decrease in temperature. The final temperature is negative 17 degrees Celsius. What was the final volume of the basketball after it's been frozen? So we'll be doing the Charles law. So let's first list our knowns and unknowns. Unknown. So we know that the initial volume is 553.687 centimeters cubed, and the initial temperature is 25 degrees Celsius, and the final temperature is negative 17 degrees Celsius. And what we need to find out is the final volume of the basketball. So if we look at what we've got, the final temperature is negative 17, and we have a negative, meaning that when we find the answer, it will come out to be negative, which we don't want. And so since we don't want to have a negative number, then that's when the Kelvin scale comes in. Because the Kelvin scale is set at absolute 0, with an equation of K equals 273 plus Celsius, then we can get rid of the negative, and that will give us an absolute answer, absolute number for the answer. So let's convert them. So that would be 273 plus 25, which gets us 298 Kelvin, and negative 17. So 273 plus negative 17 is equal to 256 Kelvin. Okay, now that we've got the temperatures, we're gonna plug that into the Charles law equation. So Charles law equation is V1 over T1 is equal to V2 over T2. Okay, so now we need to convert to get the volume. So let's see. So it would be multiplying both sides by T2, so then that gets rid of the T2. So now it would be V2 is equal to T2 V1 over T1. So now let's plug in our numbers. So V2 is equal to, let's see, 256 Kelvin times 553.687 centimeters cubed over 298 Kelvin. So now the two K's cancels out and we're left with centimeters cubed, which is what we want. And so if we plug it into the calculator, we get 475.6505772. Wow, that's a pretty long number. So let's just round it to the nearest 10th. So nearest 10th place, so then that would be V2 is equal to 475.65 centimeters cubed. And that is your final volume. Boyle's law can be defined as when the temperature of a specific gas is held constant, the volume of the gas will be inversely proportional to the pressure of the gas. The formula for Boyle's law can be shown as pressure 1 times volume 1 is equal to pressure 2 times volume 2. So here we have this mini lung model, and we will be using this to demonstrate Boyle's law.
According to Boyle's law, when you increase pressure, the volume decreases, and vice versa. So when we increase the volume of the lung, pressure decreases.
And so if we pull on this plastic bag, the balloon inflates. But if we push it back in, the balloon deflates. So this tells us that when we pull the plastic bag, pressure are being expelled, thus causing the volume inside to increase. So this agrees with Boyle's law, because if pressure decreases, the volume increases. And now if we push it back in, adding pressure to the balloon, then the balloon decreases. So this also agrees with Boyle's law. Okay. Okay, now we will be doing Boyle's law. So let's take a look at our problem. For a school project, you are to make a model of the human lung. A balloon is attached to a plastic bottle with a bag attached to the bottom to manipulate it. When the bag is pulled, the balloon inside the bottle inflates, and when the bag is pushed back into the bottle, the balloon deflates. Excellent! Now that your model shows a representation of how the lung works, let's find out how much pressure was inside the balloon after you've inflated it. When the balloon was deflated, you had a volume of 22.44 centimeters cubed and contained a pressure of 1 atm. When it was inflated, it had a volume of 38.41 centimeters cubed. So, what was the pressure of the inflated balloon? First off, we have to list our knowns and unknowns. So let's see. We have our knowns and unknown. So, looking back at our problem, it said that the balloon was deflated, and it said that the balloon was deflated with a volume of 22.44 centimeters cubed. So that would be our initial volume. So V1 is equal to 22.44 centimeters cubed and containing a pressure of 1 atm. So our initial pressure is 1 atm. Now, it also said that when it was inflated, it had a volume of 38.41 centimeters cubed. So meaning that would be our final volume. So that would be V2 is equal to 38.41 centimeters cubed. And so now we're trying to find the final pressure of the inflated balloon. So that would be P2. Recall that the equation for Boyle's law is P1 V1 is equal to P2 V2. So we have to rearrange the variables in order to get P2. So divide both sides by V2. And so that would get us P2 is equal to P1 V1 over V2. And now let's plug in our numbers. P1 is just 1 ATM times V1, which is 22.44 centimeters cubed, over V2, which is 38.41 centimeters cubed. And look, these two units cancels out. The units cancels out, and so we're left with ATM, which is what we want for pressure. Now let's plug it into the calculator. And what we get is 0.584-222-8586. And so I'm going to round it to the nearest tenth. So that would be P2 is going to equal to 0.58 ATM. And that is our final answer.